Hi class, in this lecture here we talk about the conic section called the parabola. And you've all looked at or seen a parabola before in your previous math courses, but this is going to take a little bit of a different look at it. Kind of like how we were talking about the ellipse and then hyperbolas. This one is going to focus on a different definition than you've seen in your previous classes. Okay, so what we're going to do here, we're going to talk about how you graph parabolas with vertices at the origin. Then we're going to write equations of parabolas in standard form. And then we're going to graph parabolas with vertices not at the origin. And I'm going to do an example of all of these for you. All right, so let's start with the definition of a parabola. So a parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. Okay, all right, and that focus is not on the line. So basically what's going on here is, all right, this is a parabola here. And you can see here we have what we call the directrix. We have the vertex, the turning point. You can see I have the axis of symmetry and the focus here. And so what this means, just the definition is here. Take this point here, P. Well, let me go back. Sorry about that. Take this point here, P. All this is saying is the distance from here to the point and then from the directrix to the point is the same. So this distance, D1, will be D1. It'll be the same here. And then you could take any other point here. And then the distance from the focus to here, in here, these two distances will be the same. So it's just the point, the set of all the points such that that would happen. Okay, so if you take a point out here, again, this distance, D3, would be the same as this distance to the directrix. That's all that's going on here. All right. So the way we're going to write this in standard form. Okay, so the standard form of the equation of a parabola with vertex at the origin. Okay, so that turning point at the origin. All right, we're going to do those simple ones first, is the following. You could have y squared is equal to 4 times p times x, and I'll explain what all that is. Okay, and when you have y squared, it's going to be a parabola. I don't want to say on its side, but that would be how you would have seen it. You know, you're used to seeing a parabola that opens up or down like this. This is a parabola that opens up on the side. Okay, and what's going on here is the vertex is the origin. So the vertex occurs at the point 0, 0. And this value p here helps us find the focus and that line of the directrix. So then the focus is going to occur at the point p comma 0, and then the directrix is going to be at the line x is equal to negative p. Now if you have this one, right, x squared is equal to 4 times p times y, again, the origin is the vertex, but the focus now is going to be on the y-axis, since over here it's on the x-axis. Focus is going to occur at 0 comma p, and the directrix will now be over here it's a vertical line. Over here it'll be a horizontal line, y is equal to negative p. Okay. Keep these handy. All right, now what we're going to do is we're going to do a couple problems here. So here's the first one. I want to find the focus in the directrix of the parabola given by y is equal to, or excuse me, y squared is equal to 8x. And then I want to graph this. All right, so the first thing I want to do is I want to write in standard form. Okay, which is this y squared, if you look back. This y squared is equal to 4 times p times x, because this p value, this p right here, tells me how to find the directrix, and it helps me find the focus. All right, so I know just by looking at it, because it's a y squared, all right, y squared is equal to 8x, it's going to be a parabola that looks like this, okay? All right, so I'm going to have to look. Well, what is 8? 8 is 4 times 2, okay? So this 2 here is my p. So then I got it. All right, so my focus is going to occur at the point p comma 0. Well, I know P is 2, so this is the point 2 comma 0. And the directrix is going to be this line, this vertical line, x is equal to negative P. So x is equal to negative 2. All right, so now let me use that information to sketch it. All right. All right, so this right here we know is going to have the vertex is at the origin. Okay, so the turning point is going to be right here. That's the vertex. The focus is going to be the point 2 comma 0. And the directrix is going to be the line x is equal to negative 2. Okay, so this is the directrix. This is the focus. And there's the vertex. And then look, it's just going to open up sideways like this. So this graph is just going to look real briefly like this. And we got it. So you know, what we wanted to do was find the focus, directrix, and then just roughly sketch it. And you can see here, here's a little bit better version of it. And again, focus is 2 comma 0. Directrix is that line, x is equal to negative 2. All right, let's try another one. Let's find the standard form of the equation of a parabola with focus 8 comma 0 and directrix x is equal to negative 8. Well, look, when you go back, excuse me, when the focus here is 8 comma 0, all right, and the directrix is x is equal to negative 8. Oops, sorry, I keep making a little bit of a going through different ones. It's going to be this one again, okay? It's going to be this one right here. All right, so it helps to sketch this, okay? It helps to sketch this. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so here's the directrix. Okay. And then here's the focus. So we know it's going to look like this again. And what's going on here is they're telling you P, okay? So since I know it's going to look like this, all right, going back, it's going to be the same thing. Y squared is equal to 4 times P times X. Well, just plug in P. So you get y squared is equal to 4 times 8 times x, or y squared is equal to 32x. And there we go. All right, let's now end just real briefly talking about going back to looking at our objectives and just how you graph parabolas with vertices not at the origin here. And so this really helps here. So this is standard forms of the equations of parabola with vertex hk. Okay, so this is different from the origin. So I've got x comma y as my center. So there's two forms you're going to look at. You're going to look at y minus k squared is equal to 4p times x minus h, or you're going to look at x minus h squared is equal to 4 times p times y minus k. Okay. So looking at this here, all right, the center is going to be at hk, and so this is important. The h is with the x, and the k is with the y always. So just make sure you don't accidentally mistake that. If the squared term is with the y, it's a horizontal axis of symmetry like this. If the squared term is with the x, it's a vertical axis of symmetry. The focus is going to occur at either this one, it'll be h plus p comma k, or down here it'll be h comma k plus p. Then the directrix here, if it's this type, will be the line x is equal to h minus p, or if it's this type, the directrix will be y is equal to k minus p. And p will tell you if it's going to open to the right or left, or upward or downward. So I'm just going to focus on the positive p's here. So we're just going to do opening upward like this. All right, let's do an example so you can see how this is used. So I want to find the vertex, focus, and directrix of this parabola given by x minus 2 squared is equal to 4 times y plus 1. Okay, and then I want to graph it. Well, look here. It's going to be this one here because I've got the squared, okay, with the x. So this is x minus h squared is equal to 4 times p times y minus k. All right, so I want to, just rewriting this. So I want to rewrite this so that it matches. Okay, so this is x minus 2 squared. Well, here there's an invisible 1, so this is 4 times 1, and then y minus 1. All right, so you can see exactly what's going on here. This is my h, this is my p, and this is my k. So once you find the h, the p, and the k, all right, then it just look at how easily this falls into place. Let's find the vertex. Vertex is the point we're using this equation here, h comma k. So the vertex is the point 2 comma negative 1. Boom, we got it. The focus, because we're using this equation right here, is h comma k plus p. So this is h is 2 comma k, which is negative 1 plus p plus 1. So this gets me the point 2 comma 0. And then the directrix, so we got this, boom. So again, look, you're just following the formula here. The directrix right here is y is equal to k minus p. All right, or y is equal to, where's my k? Minus 1, which is minus 2. So my directrix is the line y is equal to negative 2. Now let's plot all these things, okay? So I know because the x was squared, it's going to look like this, okay? All right, let's plot the vertex, okay? So that's important. That's the turning point. So negative 2, 1, okay? Or 2 comma negative 1, I'm sorry. The focus is going to occur at the point 2 comma 0. Okay, there's the focus. And then the directrix, that line, is y is equal to negative 2. And you can plot extra points as needed, but what you basically see here actually is, it looked like this. It actually go through the origin like this. And this is our parabola. Okay, this is this x minus 2 squared is equal to 4 times y plus 1. We got it. And so I'm going to show you on the next slide here a little bit cleaner version of it, a much cleaner version than mine. And again, you know, what you're seeing here, as with the other lectures here, is, you know, the math is not hard here, right? Like, what's hard is like, what's my h, what's my k, you know, what's, you know, not mixing up anything, because there's a lot of steps to all of this. All right, but as always, class, if you need anything, I am here to help.